Welcome to problem 1, part B. All right, so this is how we're gonna do it. First thing I like to do here, we wanna solve this with Laplace. First thing I wanna do is I wanna rewrite this more compactly with this notation. So x dot plus 3x plus y dot equals 1, and x dot minus x plus y dot equals, oh, no, we got minus a y equals e to the t. Now we apply the Laplace because we see that there's really no way to decouple them from this form. So we apply the Laplace. What's the Laplace of x dot? Well, that's going to be s times big X of s. I'm going to omit the s for readability. Minus x of 0. Then we get 3, which can be factored out of the Laplace, applied to x, which just becomes big X of s. And then here we have s times the big Y of s, but I'm not going to write that for readability, minus small y of 0. And all of that is a 1 over s because the Laplace of 1 is 1 over s. Now we want to do the same thing to the bottom. So we get sx minus x of 0 minus big X plus sy minus y of 0 minus big Y equal to, well, this becomes 1 over s minus 1 because I remember from the table. Now, let's look at the initial conditions. So we have this initial condition and this. So right here, we get that this is 0 and that this is 0 as well. So now we can rewrite everything. Let's rewrite everything over here and factor out those x's and y's. So we get x plus 3 here. And maybe I wrote a little bit too large. S plus 3, close that, times that big X plus s times y. So plus s times y, and all of it needs to be equal to 1 over s. Now we're going to look right here, and we get s times x minus x, so s times x minus 1, so s minus 1 times x, plus s minus y times y, plus s minus 1 y. And all of that needs to be equal to 1 over s minus 1. Okay, so let me rewrite this whole thing. I want to rewrite this whole thing on here as well, because I'll show you what I do in a second. So we have this, and 1 over s, and s minus 1 x plus s minus 1 y equals to 1 over s minus 1. So now I want to eliminate the y here. To eliminate the y, I need to multiply the top by s minus 1, and I need to do it to both sides of the equation if I don't want to change the inequality. And the bottom I want to multiply by negative s. So here I multiply it by negative s. Okay, and now I want to add these results up. That's a negative. So I know that the y is going to cancel out. That's what I intended to do with this. And if you notice, s minus 1 times s, y minus s times s minus 1y, those two cancel out. And then here we're going to have s minus 1 times s plus 3 minus s times s minus 1. All of it is times big X. And then here we're going to have s minus 1 over s minus s over s minus 1. So now I can get that my x is equal to s minus 1 over s minus s over s minus 1 divided by s minus 1 times s plus 3 minus s times s minus 1. Now I can do the right-hand side. Now I want to cancel the x. So to cancel the x, I need to multiply the top by s minus 1 and the bottom by negative s minus 3. Does that check? Because I want to cancel the x. So I want to multiply by negative s minus 3. So here, minus s minus 3. Not minus 1, minus 3. And here, times minus s minus 3. Which is the same thing as negative s plus 3. So here, I actually want to write, let me move this. Here, I want to write s minus 1, and here s plus 3, the minus of that, which is the same thing as this. Well, what do we do now? Well, now we add them up, and we notice that someone cancels out, this cancels out. So then now we just have s times s minus 1. Actually, I wanted the negative there because I'm trying to make the denominators the same. So let's put that negative over here. Shouldn't change much. This, I forgot, should also be minus s plus 1. This should be s plus 3 now. And so that part still cancels. But here we're going to have s minus 1 times s plus 3 minus s times s minus 1. Y equals to negative s plus 1 over s, which is the same thing as minus s minus 1 over s, and plus s plus 3 over s minus 1. Now that we have this, we get the big Y is going to be equal to negative s plus 1 over s plus s plus 3 over s minus 1. All of it divided by, that's a negative, s minus 1 times s, and I need a parenthesis here, times s, let me make this better, times s plus 3 minus s times s minus 1. I don't need that bracket anymore. And now we want to put these in part frac. So with MATLAB, let's see what we get out of this. And I'll show you how to do this whole problem in MATLAB in the second part of this video. So I go over to MATLAB, and I put in the part frac, we have s minus 1, which needs to be in parentheses, s minus 1 over s, minus s over s minus 1. This whole thing, so I need to put it in parentheses again, needs to be divided by a denominator, which is parentheses, parentheses, s minus 1 times s plus 3, close that, minus s times s minus 1. And then we have a whole other one, so copy this, paste over here. The denominator is going to be the same, but the numerator change is going to be negative s plus 1 over s and plus s plus 3. This is very error prone. Let's be very careful with this. S plus 3 over s minus 1. and all of that is divided by. So let's see. S minus 1, I'm looking at this one. S minus 1 over S, let's see if I wrote it right. So here I have S minus 1 over 2. No, it should be S minus 1 over S. Over S. So S minus 1 over S minus S over S minus 1. And then these two close together. And then S minus 1 times S plus 3 minus S times S minus 1, which is the same as this one right here. But for this guy, we get negative S plus 1 over S plus 3 over S minus 1. S plus 3 over S minus 1. And then all of these together are divided by the same denominator. So I press Control Enter. And if we didn't make any typing mistakes, we get the following. So for the first one, with the S minus 1, I get 1/3 times 1 over S minus 1/3 times 1 over S minus 1 squared minus 1/3 1 over S minus 1. For the latter, for this one, we get 1/3 1 over S minus 1 plus 4/3 times 1 over S minus 1 squared minus 1/3 times 1 over S. So now if we apply the Laplace inverse, let's do that. We get that small x of t, we're back in the t domain. Now we're going to look over here. What is the Laplace inverse of 1 over S? It's 1. So we get 1/3 multiplied by that 1. And let me make that 1/3 a little bit better. 1/3 times 1 minus 1/3. Here now, where do I get that one? Because I don't remember the pattern for that one. Well, we have that into the S minus 1, so it seems to be e to the at times t to the n, where n is 1. So e to the at, where a is 1, this is going to be e to the 1 times t. And then we have minus 1/3. These are still all the constants that we bring out. E to the t. And then we need to look at this one and apply the Laplace inverse here. So we apply the Laplace inverse here. We're going to get the small y of t is going to be equal to 1/3 e to the t plus 4/3 e to the t times t minus 1/3 times 1. So these should be our two answers. We can write them over here. X of t is equal to 1/3 minus 1/3 e to the t times t minus 1/3 e to the t, and y of t is equal to 1/3 e to the t plus 4/3 e to the t times t minus 1/3. And now I'm going to show you how to do this in MATLAB. I'll see you there.